Hello there, my dear students. Today we'll be trying to solve a problem from solid state chemistry. So let's see what the problem is and how to solve the problem. So what is the aim of this problem? In this problem, we are going to find the density of a molecule or an atom. When we know the other parameters like the type of the unit cell. From the type of the unit cell, we will know Z. What is Z? Z is the number of atoms that is present in one unit cell or number of atoms per unit cell. And the other parameters that are known are the molar mass and the edge length of the unit cell, which is given by the symbol A. We are also going to find the number of unit cells in a given mass of the atom or molecule. So now let's see what the problem is. So this is the problem. An atom X with atomic mass 40 gram per mole has FCC structure and unit cell edge length of 400 picometer. Calculate the density of X and number of unit cells in 4 grams of it. Now, what is the data that is given? We are given the atomic mass or the molar mass of the element. So the molar mass is given, and then we are given that the atom forms FCC lattice. What is FCC lattice? FCC lattice means it is face centered cubic lattice, or the atom forms a face centered cubic lattice. So the number of atoms in one unit cell in an FCC lattice Z, that is equal to 4. So we know the molar mass M, which is equal to 40 gram per mole. We know that Z is equal to 4, and then the edge length A is given as 400 picometer. What is the unit of density? The density is generally given in gram per centimeter cube. So D, the unit is gram per centimeter cube. Therefore, A, you have to write it in terms of centimeter. So it is 400 picometer, or 400 into 10 to the power of minus 10 centimeter. So from this data, we have to find the density and also the number of unit cells in 4 grams of the atom. Let us first calculate the density of the atom. Now the formula to be used is D is equal to mz upon Na multiplied by A cube, where D is the density of the atom or the element. This we have to find. M is the molar mass of the atom or the element. Z is the number of atoms per unit cell in the crystal lattice, and Na is the Avogadro number. The Avogadro number value is 6.022 into 10 raised to the power of 23, and A is the edge length. So now we have to substitute the values in the formula. D is equal to mz upon Na into A cube. So M is 40 gram per mole, A is 400 into 10 to the power of minus 10 centimeter, Z is, because it is an FCC lattice, Z is equal to 4, number of atoms per unit cell. And we know that Na is Avogadro number, which is 6.022 into 10 to the power of 23. Now let's substitute it in the formula. So we get it as D is equal to 4 multiplied by 40 upon Avogadro number 6.022 into 10 power 23 into 400 into 10 power minus 10 the whole cube. Since calculators are not allowed, I have solved this problem step by step, and you can have a look at it. You can also pause the video and try to do it by yourself and check out the answer for yourself. So the final value, the density of the atom, works out to be 4.15 gram per centimeter cube. Now let's find the number of unit cells present in 4 grams of the atom. So for this, first what we will do is to calculate the number of atoms present in 4 grams of the atom. Now we know that one unit cell has 4 atoms. Why? Because this is an FCC lattice. So the number of unit cells will be equal to the total number of atoms upon 4, because one unit cell has got 4 atoms. Therefore, if I have x atoms in 4 grams, then it will be x upon 4. So the total number of atoms upon Z, the number of atoms in one unit cell, will give me the number of unit cells. So let's calculate the number of atoms in 4 grams of the atom. We now use the mole concept. So 1 mole of the atom weighs 40 grams. Why? Because the molar mass is 40. And this will contain Avogadro number of atoms, that is 6.022 into 10 to the power of 23. So we now have to find the number of atoms in 4 grams of the atom. So 4 grams will contain 4 multiplied by Avogadro number upon 40. So this will work out to be 6.022 into 10 raised to the power of 22 atoms. So these many atoms, that is 6.022 into 10 power 22 atoms, are present in 4 grams of the atom. So we have now found the number of atoms in 4 grams of the element. Now find the number of unit cells in 4 grams of the atom. So 4 atoms make 1 unit cell. So 6.022 into 10 power 22 atoms will make 6.022 into 10 power 22 upon 4. This will work out to be 1.055 into 10 to the power of 22 unit cells. So we have 1.055 into 10 to the power of 22 unit cells in 4 grams of the atom. So this is the answer, 1.055 into 10 to the power of 22 unit cells. So we found both the density and the number of unit cells in 4 grams of the atom. I hope you found this session useful. If you found this session useful, please don't forget to share this with your friends and also hit the like button. Also consider subscribing to my channel. Until I see you with another interesting topic in chemistry, this is your chemistry teacher Suja signing off. Take care and bye-bye.